So here's the first lab that I want you guys to explore, and it's just an introduction to transverse standing waves where you can practice the terminology that we learned in the videos above. The first part of the lab is just answering questions around this picture. So here is a standing wave generated by a speaker vibrator and a weight hanging on the string. The weight supplies the tension in the rope, and the vibrator changes the frequency of oscillation. So in this picture, you can see this looks like the third harmonic. And using that picture, you should be able to calculate the wavelength or answer any of the questions that they have here. Okay, that'll be automatically graded. And then after answering those questions, you are going to click on this expandable window, the Standing Waves Interactive. Okay, and here is the basic setup of the lab where we can actually try to play around. Let's start with the first chord and a 50-gram weight. Okay, so I'm going to click there, 50-gram weight. And I'm going to click go. Okay, these tools I already have open. So if I open up these tools, I can set up this ruler over here, and I can set up the vertical ruler and the horizontal ruler. This horizontal ruler will allow me to calculate the wavelength of the oscillating string, and that vertical ruler I'll be able to look at the amplitude. I need to see the amplitude of that standing wave. So let's just see what it looks like. I'm just going to click play. All right, and what you can see is that's the frequency reading. Oh, at around 10 hertz, we got our first harmonic. At around 20 hertz, we got our second harmonic. At around 30, we got third harmonic. 40 is the fourth harmonic. 50 is the fifth harmonic. And 60 is around the sixth harmonic. Okay, so I can take those measurements. Okay, first harmonic, second harmonic, third harmonic, fourth, fifth, and I can record the frequencies. And that would allow me to make a graph. And I wonder, that graph looks like it's going to be linear. So I wonder what that graph, the slope of that graph is going to mean. So you can go back into my video and look at a formula that we created. The mass over here is equal to the tension. So the weight of gravity on that mass is equal to the tension in that rope. All right, that's part of the formula. And then you have these rulers here to measure the wavelengths and whatnot, and you can pop that into the formula. And so somewhere in the slope of that line will be a constant. For example, the mass per unit length. I have the length of the rope. Okay, it doesn't tell me what the mass of that rope is, so I could be able to figure out what the mass of that rope is using the slope of the line on this graph. So just for something for you to think about. Okay, and then you can go back to this and you can even change the mass and see how does doubling the mass on that rope affect its oscillation frequencies, okay, for the harmonic. So let's just look at that really quick. Okay, so we doubled the mass. Oh wow, the first harmonic is around 16 hertz, so that's not the same as the last one. Okay, second harmonic is 32. Okay, I'm not going to ruin it for you, but you can see that if I change the mass, I'm changing the tension. I'm going to be adjusting the frequency that causes these oscillations. So you can play around with that just to get a good idea how to use that formula. Okay, and then you'll be using the same experiment for the next lab.